Okay, so I'm going to make an attempt at making a video. This is actually my second attempt. First one didn't work out too well. We'll see. So I'm talking about 10.2.2 in case you missed Monday, Tuesday lessons. So it's talking about graphing exponential equations. One of the first things it asked you to do was to graph um, the equation b to the x, where you got to pick some b value that was greater than 1. So I chose to do the b value of 2 just because it's an easy number to work with. We'll talk about what happens if I choose a different number in just a second. Um, but 1 and 2 ask for the positive and the negative x. So you can kind of see them here in blue. This is the function 2 to the x power. A couple of properties to kind of point out on these both. Number one is that they both go through the point 0, 1, because any number raised to the 0 power is always going to be 1, doesn't matter what number it is. So if you don't have any translations happening, nothing adding and subtracting to the x value or the y value, then it's going to go through the point 0, 1. And this is a point that I'm going to use as a reference as I start doing my translations a little bit later on. The other point to point out is that both of these approach 0. So we have a horizontal asymptote happening here at y equals 0. The reason why this happens is because if you remember from your exponential properties, when you look at something like 2 to the x power, right? If I were to plug in a negative number, 2 to the negative 1, well, exponential properties state that that can drop to the denominator. So 2 to the negative 1 is the same thing as 1 over 2 to the first power. So you get 1/2. Same thing with negative 2, right? That would be 1 over 2 squared, which is 1/4. So the further we go down, the further to the left, so the more negative these numbers get, the larger the denominator gets, right? Because the next one would be 8 and then 1/16 and 1/32. So that denominator is just getting bigger and bigger and bigger and bigger. So the bigger the denominator gets without the numerator changing, the closer this thing gets to 0, because those fractions are going to get itty, 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 bitty. So just keep that in mind. I do want to point out that if you're on Desmos and you're tracing these graphs, they do eventually look like they get to 0, but it's only because Desmos only goes out to 3 decimals. So once you get to the point where it's 0.000 and then some number, then it just calls it 0 because it doesn't go out past the third decimal. So it looks like it gets to 0, but it's never actually going to do that because there isn't a single number you can plug into this function that's going to give you 0, because 2 to the 0 power gives you 1, right? And then obviously 2 to any other exponent gives you some number. So just keep that in mind. There is an asymptote at 0. And then 2 to the negative x here. Once you plug in a negative, so this thing is just going to go the opposite direction. Because if you think about it, if I plug in a negative exponent, well, that's going to be 2 to some positive number. So it's going to be big on this negative side. And then once you plug in positive numbers, they're going to be negative. So they're going to get really, really small on the other side. So this is a horizontal reflection about the y-axis. There's some special properties that we need to talk about in a little bit once we start translating, but I want to talk about domain and range of these first, and then we'll go there. So domain and range of these, if I'm looking at the domain, so I'll make a little sketch real quick of this graph, right? So we just talked about the fact that at 0, it goes through 1. Hold on, make some points here. I'm going to put X's only because this thing doesn't like to put circles. So there's going to be 1 there. Oh, look, I can make an open circle. These are closed circles. It just doesn't like closed circles, so I'm going to make them open. We just said at -1, it would be at 1/2, right? And then at 1, 2 to the first power is just 2. So this graph looks something like this. It goes through those points, takes off that direction, it ends up close to those asymptotes. Pardon the horrible graph. But when I'm looking at something like this, domain, right? You're talking about the left to right when you talk about domain, right? So from left to the right. There's nothing here that I can't plug in for the x value. I can plug in all negative numbers. I could plug in 0 and I get a value. I can plug in positive numbers and it just gets bigger and bigger numbers. So there's not a single x value that I can't plug in there that's going to give me some undefined function. So the domain here is just all real numbers, and you can use the all real number symbol, or interval notation would be -infinity, right, to +infinity. Okay, don't write both. Those mean the exact same thing. So it's one or the other. They're not, you can't use both. So then next up would be range. All right, when we talk about range, we're going from bottom to top, always negative infinity, up to positive infinity. So we're going this direction. All right, so this graph doesn't start until we get to our horizontal asymptote of 0, right? Because this thing's just going to keep traveling along with it, and it's never going to pass it. So this thing is going to start at 0, right? And then it goes just on and on and on forever, because this thing will just keep getting bigger and bigger depending on how big the x value is that I put in there. So 0 to positive infinity. Okay, so that's kind of what that thing's going to look like. Just for the sake of talking about it, in case it shows up, if I wanted to talk about the end behaviors, right? Remember, we always look at both directions. So as x approaches negative infinity is one of the directions. So as x goes in this direction, right? So we're looking at this end way over here. What does the function do? Well, the function, the further we go out in that direction, is just getting closer and closer to the 0 over here because it's getting closer to the asymptote. So this thing's going to approach 0 on that end. So that would be the left end behavior. So the as x approaches negative infinity. We can also take a look at the other direction when x approaches positive infinity. All right, so as x approaches positive infinity, so as it goes this direction, all right, well, that would be this end over here. So as we go out towards the end, it won't let me circle it. There it goes. So as x approaches positive infinity, what is the function there doing? Well, if we take a look at that function, as we get bigger and bigger x values, this thing just gets bigger and bigger. So as we approach positive infinity, this thing is just going to take off to positive infinity, right? If you think about real big numbers, 2 to a million or 2 to a billion, like it's just going to continue to get bigger and bigger and bigger and bigger. So this thing just takes off towards infinity on that side. That's just in case they throw something at you like end behavior, right? Because that's from the last unit. So you should be able to do those types of things. So there's your end behavior. So now going back to a few other things I want to kind of look at on graphs. So one of them is what happens if I chose a bigger number or a different number, right? So still looking at ones over 1 for right now. We'll talk about the other in just a second. Notice that it still goes through 0, 1. It still has an asymptote at 0. The difference here being that it just takes off faster, right? Because if you think about 9 to the first power, so when x is 1, y would be 9. So that thing's going to go way up here and cross here at 9. So the only thing that's different between these two things is just that it's going faster, right? I do want to point out that this is not considered to be a vertical stretch, because this is a change in base. So this is a totally different base. It's really a totally different graph. It's still exponential, but that's not necessarily considered a stretch. If we wanted to do a vertical stretch, which of course we know is the multiplying by a value, that would actually be a multiplication. So if I want to do a vertical stretch of 3 times, we'll do the 2 to the x1, 2 raised to the x power.